Right, conjugates of complex numbers. Okay, so if we have a complex number a plus bi, then its conjugate is a minus bi. And if you had a minus ba, the conjugate would be a plus ba. Here's some examples. Let's look at this one here. 14 minus 5i. So the conjugate is 14 plus 5i. Now have a look over here. Now the reason why I want to do this one first is, look, negative 3 plus 7i has a conjugate of negative 3 minus 7i. I didn't change this negative 3, okay? It's this sign in between the two, okay? Just over here. Positive 14 minus 5i, positive 14 plus 5i is the conjugate, okay? And also here, simple ones, 8i, so negative 8i is the conjugate. Right, let's have a look at these. Okay, so conjugates, by the way, look at this down here. The product of a complex number and its conjugate is a real number, and it comes in useful. Here we go. 5 plus 7i, so the conjugate is 5 minus 7i. Now, if I was to do the distributive law, in other words, a FOIL on this, now look at this. Pen. 5 times 5 is 25, okay? Now think of the outer. 5 times negative 7i is negative 35i. Okay, negative 35i. But look at the inner. Positive 7i times 5 is positive 35i. Can you see that they will cancel? Okay, negative 35i, positive 35, 0. And the last, finally the last, is negative. Look at this. Next down here. I'm going to jump straight to here now, okay? Because remember, I don't need the outer and the inner. Remember that when you're doing the conjugates, okay? You don't need to do the outer and the inner because they will cancel just for these, just for the conjugates. So just do the first and the last. So, because I get negative 49i squared and I squared is negative 1, I'll get positive 49. And that's why, okay, this part A is actually 74. You could write it like this, 74 plus 0i if necessary, okay, but there you go. So that's just you doing FOIL, distributive law on conjugates. You end up with an actual real number. Now look at 8i times minus 8i. This is actually simpler. What's 8 times negative 8? It's negative 64. What's I times I? It's I squared. The I squared is negative 1, so it changed it to positive 64. Okay, so can you see these conjugates? Because one is plus and one is minus, it's always going to be a minus, but the negative 1 from the I squared will change it back to a plus. Okay, so conjugates useful when we divide by complex numbers. Let's have a look. Divide 2 minus 5i by 1 minus 6i. Right, okay, here it is. Okay, that's what we're starting with. What we do is we multiply by the conjugate. There it is. So I'm multiplying both the top and the bottom by the conjugate. It's a fraction. Whatever I do to the bottom, I've got to do to the top. So here's my setup. All of this is just me setting it up. Okay? Right, I'm multiplying by the conjugate. And the reason why I do it is think about what we did last time. Okay? All I'm going to do is do the first and the last. What's 1 times 1? Let's get the arrow up here. 1 times 1 is 1. What's negative 6i times positive 6i? Well, that will give me negative 36i squared. Remember what the I squared does? Changes it to a positive 36 because I squared is negative 1. So that's what I'll have. And lo and behold, look at this. I get 37. There you go. It's easy to the denominator. Let's do the numerator. That's more awkward. Okay, because it's not a conjugate. It's 2 times 1. So here we go. I'm going to do this right here as a FOIL. 2 times 1 is 2. The outer, okay, the outer, 2 times 6i is 12i. The inner, negative 5i times 1, negative 5i. Negative 5i times positive 6i, negative times positive, that's negative 30i squared, but the I squared is negative 1, so it'll change it to positive 30 right at the end here, okay, this bit here, and there it is. So I just add what I can. 12i take away 5i is the 7i here. 2 plus 30 is 32. And there, that's my final answer. Okay. But if I write it in two separate parts, 32 over 37 and the 7i over 37, there it is. Okay. That's it. Last one, very quickly. Okay, so if I divide by a conjugate, Okay, so 1 minus 6i, I'm using 1 plus 6i, but what about this one here? Okay, divide that. Now here you're not really using conjugates. You don't have to do this. I mean, you can do. Remember the conjugate of 8i was negative 8i. But actually, all you really have to do, I'm going to erase that, because I'm trying to get to a nice whole number. Well, all I really need to do is do this. Multiply by I. Okay? Because I times I is I squared, and I squared is negative 1. I'm changing it to a real number. So that's all I have to do in this form, because look, numerator, 3 times I is 3i. 8i times I is 8i squared. But remember, I squared is negative 1, so this is just negative 3i over 8. Okay, because I'm just changing that to negative 1. Okay, and there you go. That's you doing conjugates.